Our planet is a delicate and intricate system, where the smallest organisms can have the most profound impact. For millennia, we have looked to the great forests and vast oceans as the lungs of our world. Yet there is another power, an unseen, often overlooked force of nature that holds remarkable promise. These simple aquatic plants are among Earth's most ancient life forms. They have shaped our atmosphere for billions of years and produce a significant portion of the oxygen we breathe. Now humanity stands at a critical juncture, facing climate change and resource depletion. We are turning to these humble organisms for solutions. The algal biorefinery is emerging as a beacon of hope. It represents a paradigm shift in how we produce energy, food, and materials. An algal biorefinery uses algae, this remarkable green gold, as raw material. It can capture harmful carbon dioxide, purify wastewater, and create valuable resources all at once. This is not science fiction, it is a tangible, rapidly developing field. By harnessing algae's photosynthesis, we can create closed-loop systems, turning waste into wealth and pollution into products. The potential is extraordinary. The urgency demands bold, innovative thinking. Reliance on finite fossil fuels brought prosperity at great environmental cost. The time has come to find sustainable alternatives that power society without destroying nature. Algal biorefineries offer that pathway, moving away from take, make, dispose toward a circular model. It is a vision of a future in balance. The natural world operates in magnificent circles. Nothing is ever truly wasted. A fallen leaf provides nutrients for the soil, feeds the tree that grew it. For too long our human economies have operated in a straight line. We extract resources, manufacture products, and then discard them as waste. Algal biorefineries are a perfect embodiment of circular philosophy, integrating into industrial systems. Consider a power plant that emits carbon dioxide. Integrated with an algal biorefinery, that CO2 becomes a vital nutrient. The algae absorb this greenhouse gas, using sunlight to convert it into energy-rich biomass. This closes the carbon loop, helping mitigate climate change. Algae can be cultivated in wastewater from our cities and farms. The water is rich in nitrogen and phosphorus and would otherwise cause harmful algal blooms. In a controlled biorefinery, those nutrients fertilize the algae. As the algae grow, they systematically strip pollutants from the water, achieving over 90% removal. Once harvested, the algal biomass becomes the starting point for a cascade of products. We extract oils to create biofuels for transportation. The remaining proteins become animal feed or bioplastics that replace those derived from fossil fuels. Each step creates value with very little waste, the circular economy in action. It regenerates, restores, and adds value at every turn. To unlock algae's potential, we must cultivate it efficiently at massive scale. Large, shallow, oval-shaped channels with water circulated by paddle wheels. For more controlled approach, we have developed photobioreactors. These closed systems provide highly regulated environments where we can control every parameter. This allows us to cultivate specific strains and achieve much higher biomass densities. Photobioreactors protect from contamination, making them ideal for pharmaceutical-grade products. The journey from single-cell to harvestable crop is biological engineering marvel. The process begins with a small inoculum of chosen algal strain. Provided with light, CO2, and nutrients, these cells multiply at astonishing rates. Some species can double their biomass in a single day. As the culture becomes dense, turning the water deep green, it's time for harvest. This is done through flocculation, followed by centrifugation or filtration. Once harvested, the real work of the biorefinery begins. The wet algal biomass is a complex mixture of valuable components. Through techniques like solvent extraction, we separate valuable oils, which are precursors to biodiesel. Further refinement yields bioplastics, biofertilizers, antioxidants, and pigments for food and cosmetics. Each step is careful dissection of this remarkable raw material. Around the world, pioneering companies are putting these principles into practice. In the United States, projects integrate algal cultivation with industrial facilities. In Europe, algae are integrated with wastewater treatment for valuable products. In the Netherlands, closed-loop systems cultivate omega-3 rich strains. In Australia, vast pond systems prove algae can be economically feasible at commercial scale. Success comes from diverse product portfolios, high-volume biofuels and high-value specialty chemicals. Each facility is a living laboratory, refining designs and building practical knowledge. The field of algal biotechnology is in constant rapid evolution. Scientists are using genetic engineering to design algae tailor-made for specific tasks. Engineers are developing novel cultivation systems, even integrated into building facades. Biofilm systems make harvesting as simple as scraping algae off conveyor belts. We're discovering new uses: biodegradable bioplastics, construction materials, even electronics. As we explore molecular secrets within these organisms, the potential products will only grow. The journey forward is not without challenges. The greatest hurdle remains economic. Scaling from pilot hectares to commercial thousands of hectares creates engineering challenges. Maintaining stable, productive cultures requires sophisticated monitoring and robust strains. To compete with subsidized fossil fuels, the algal bioeconomy needs supportive policies. Building public awareness and acceptance is equally important for widespread adoption. Despite challenges, reasons for optimism are overwhelming. The fundamental science is sound. The potential benefits are enormous. Algae offer a pathway to address climate change, water scarcity, and resource depletion. They are a cornerstone of the circular economy. Progress has been extraordinary, and the pace of innovation is accelerating. With continued dedication from scientists, engineers, and policymakers, we can overcome remaining hurdles. Algae, these humble and ancient organisms, hold power to help us build a cleaner future. A future where industry works with nature, not against it. Where the smallest organisms help heal our planet and secure prosperity for generations to come. The algal revolution is not just possible, it is inevitable. The future is green, and it starts now.